When we're dealing with systems and industrial engineering, we're basically trying to select systems out of the universe of all possible systems going forward. So one option for thinking about system scoping is just to think in terms of the universe. I've drawn a dotted circle here only because there really are no limits to the universe, but everything out there could be within the realm of our analysis and purview when it comes to analyzing systems. But ultimately, our interest is in analyzing individual systems. That becomes our job as engineers, is to design and construct systems. But we need to deal with how those systems interact with the universe around them. No system exists in isolation. There's no truly closed system in that sense. So as engineers, we have to pay attention both to the system that we think is in our scope and the broader universe within which it resides. To do that, we have this element of the non-system aspect of the universe that we care about being something we refer to as the environment. Now, depending upon the scope and type of your project, the environment may be very little bit more than just your system or a tremendous amount and scope beyond your system. So the scale of the environment relative to the universe is a function of how big a system you're dealing with and what kind of external factors you're interested in as things go through. If I'm modeling a toaster in my kitchen, I might care about the environment with relation to how flat the surface is that it's sitting on and the predictable amperage and voltage available to my power source. But beyond that, my toaster doesn't care that much about the environment. If I'm modeling a new hospital in a city, a large-scale social system, I care about the entire environment of the city and the metropolitan area in which it will be served, as well as overall the national health system in which it resides. So the environment for a hospital would be huge by comparison. So how you talk about the environment of your system will differ based on the kind of system that you're dealing with. We tend to have this notion of an extended system, though. That's really what I want you to focus on here, is as engineers, we tend to model extended systems. An extended system is your system, or the system you're primarily interested in, plus those environmental variables that you believe are important to an understanding of the core system or the engineering of the core system. That there's, again, this boundary. And again, the extended system could be a lot of the environment or very, very little of it. But to the extent that there are environmental variables that we care about, some of them we don't care enough to actually model them into our engineering thinking, and others we do. So the extended system is the actual system that we work on. It's the core system we're interested in, as well as those extensions to the system that are relevant to our engineering. If I'm in healthcare and I'm dealing with emergency department medicine, a child is brought into the hospital, they have a marble stuck in their nose. The marble isn't part of them as an organizing system, but it's clearly part of the extended system that I care about in that particular environment. So in healthcare in particular, we're often dealing with foreign bodies and viruses and genomes different than ourselves that get into our human bodies. And as healthcare professionals, we tend to want to model not just the organism or the patient as a system, but the extended system within which it resides. For a patient's system, that could be their socioeconomic status, their job, the environment in which they live. All kinds of environmental variables could be very, very important to an understanding of a patient or an organismic system. We don't try to say those factors are part of that system. That would be silly. But there are extended environmental variables that are very, very important to our engineering, and we consider those the extended system. So when, as an industrial or a system engineer, you talk about a system, try to keep in mind you're always talking about the extended system, which means you want to keep the variables and factors in engineering of environmental variables isolated, or at least somewhat separated from the engineering and description of the actual system variables we're interested in. Because very often the systems we produce get moved to a different environment, and therefore the extended system that we've modeled needs to be tailorable or customizable to work potentially in other environments. Sometimes not, it might not be in our scope. But we want to make sure we isolate in our engineering those variables and factors that we consider part of the modeling of the extended system, so that when our system is moved to a different environment, or if that environment changes in a substantial way, we can isolate and understand the impact on that. So again, as industrial and system engineers, we don't just implement or design systems, we actually engineer extended systems.